Hi, my name is Charlie, and you can also call me the guitar boy. Today, we are going to be treating another chemistry topic. We are still on the topic of atomic structure. This is atomic structure 5. We have done 1 to 4. This is number 5. In order for we to be able to touch the topic of atomic structure very well, that is why we decided to break it into short videos so that we can be able to touch most important aspect about atomic structure at this level. So today the subtopic we are going to be talking about is S-ray slash the discovery of neutron. S-ray slash the discovery of neutron. The person that actually discovered S-ray, the person that discovered S-ray is Roentgen. Roentgen in the year 1885. In the year 1885, Roentgen discovered X-ray. How did he discover X-ray? He discovered X-ray from a discharge tube, also called, you can also call it an X-ray tube. He discovered it when the high energetic stream of electron from the cathode of a discharge tube collide with the anode of a discharge tube. There was a radiation, a penetrating radiation that emitted from the anode. So Roentgen called this penetrating radiation X-ray. Just like this, before now we talk about how J.J. Thomson discovered electron, how J.J. Thomson discovered electron by passing a high PD through a discharge tube at a low pressure. We also talk about cathode ray, a stream of electron that we got from a discharge tube when you pass high PD across a discharge tube at low pressure. That now tells you that cathode ray is different from what X-ray. When those cathode ray, we have anode here. When those rays collide with this high energetic electron from the cathode collide with the anode, Roentgen noticed a radiation like this, a radiation from the anode, and he called this radiation, Roentgen noticed a high penetrating radiation from the anode, and he called this radiation S-ray. So which tells you S-ray is different from cathode ray. Cathode ray is caused as a result of the it's gotten as by passing a high potential difference across a discharge tube at low pressure, while X-ray is caused as a result of the bombardment of the anode by cathode ray. You get what? S-ray. That was how Roentgen discovered S-ray. Now, from there, another scientist, Mosley, in the year 1914, was able to assign a number to different elements based on the frequency of this radiation they emit. That is the X-ray radiation. He was able to assign a number, and he called this number atomic number. Mosley was able to assign a number to each element when it used them by using them as the anode. This is the cathode. So he puts one element here, he noticed the frequency of its radiation. He puts another element, notice the frequency of its radiation. He puts another type of element, notice the frequency of radiation. In all that, he was able to assign a number to different elements by based on the frequency of the radiation they emit after they were being bombarded by streams of electron from the cathode. So he was able to assign, and he called this number atomic number. So this is where atomic number comes from. He was able to assign atomic number to elements due to their the frequency of radiation they emitted after they have been bombarded by streams of electron from the cathode, that is cathode ray. Okay. Now, before now, we talked about how Rutherford discovered proton, and how Rutherford discovered proton with the assistance of his boys Giga and Marsden. And in further calculation by Giga and Marsden still, they were able to determine the mass of proton in an atom, and they found out that the mass of proton was half the mass of an atom. The mass of proton was half the mass of an atom. Now look at the equation. This one now brings all scientists, that was not like now bring another question to all scientists as at that time. If we say, for instance, an atom is, let's take carbon for instance, the mass of the relative mass of carbon is what? 12. And we talked about, we have discovered at this level, we have not discovered the third particle of an atom, which is neutron. Now we just know two now, which are what? Electron and proton. And we are told that we were told that the mass of electron is negligible, that it is very, very small. Whether you add it to the mass of an atom, whether you don't consider it, it does not matter, because when you add it, it will not show. If you don't add it, it will not show. You can neglect it, you can throw it away. So which means whenever you are talking about the mass of an atom, you don't necessarily need to talk about the mass of electron. Now proton was further was later discovered after the discovery of electron, and the mass of proton was discovered to be half of the mass of an atom. Then what now constitutes the remaining half of an atom? What now owns the mass of the remaining half of an atom? Like we are saying, this is carbon, the relative mass of carbon is 12. We are saying the mass of proton in this carbon now is half, which is what? 6. Now the remaining 6 of this, what now constituted? It was not a big question that demand an answer to as at that time. Then this made Rutherford, their master, now said, suspect the presence of another particle inside an atom. However, he said if there must be another particle inside an atom, this particle must not be what? Charged, because the neutrality of an atom has been balanced by the presence of proton and electron. Because in an atom we have equal number, we have been able to calculate that we have equal number of proton as electron prior to this particular video. If you go and watch the previous video, you will see that. So we have been able to get that. So which means the number of positively charged cancelled out the number of negatively charged, which tells us that the atom is neutral. Now if we now say, okay, there is another particle inside an atom, that tells us that particle must not carry charge. If it carries charge, which means an atom will not be neutral. Again, we must balance it for it to be neutral. So that was how Rutherford now talked about it, and he said, okay, if there must be another particle inside an atom, this particle is going to be neutral. It will not carry charge. So the person that now finally discovered this particle was Chadwick in the year 1932. Chadwick was the person that finally discovered the presence of this other particle, neutron, inside an atom. How did he discover it? He bombarded a thin sheet of beryllium with alpha particle. When he bombarded a thin sheet of beryllium with alpha particle, neutron was discovered. Now we have been able to see the people and the process with which the particles of an atom were discovered inside an atom. So we said in a recap, we said that electron was discovered by J.J. Thomson, proton was discovered by Rutherford, and we said Röntgen discovered X-ray. We said that Mosley was able to assign atomic number to different elements by the amount of X-ray that they emit. And finally, with Chadwick in the year 1933. So this is how the subparticles of an atom were discovered. We are going to, in our next video, we'll be talking about how these particles are arranged inside an atom, especially that of electron. We are going to be deliberating much on how they are arranged, how they behave inside an atom, as this is crucial to chemistry at all levels. The behavior of an electron basically explain the chemical reaction we see today, we talked about today when we say chemical reaction. So we are going to be talking about that in our subsequent video. If you are in Edo State and you are in Benin City, you are looking for physical classes, we are in Edo State, Benin City, Saple Road Bypass, Oka 1. We are close to Belisima Junction. Come and join us. We can't wait to have you with us as we are ready, ever ready to teach you those things you need to passing your exam. Thank you for watching. We'll see and meet in our next video. Bye. God bless you.